Alright, this is about the 800th time I've tried to do this today. We're going to solve a little problem here for you guys while I'm gone. We're going to solve letter J here. I've already written the formulas down over here, and I've got my little calculator up here. So we're going to look at a kangaroo is capable of jumping to a height of 2.62 meters. We want to determine the takeoff speed of the kangaroo. Remember, speed and velocity are the same thing, so we're trying to find the initial velocity of this kangaroo. Well, let's draw us a little picture down here. I'll make him a little orange kangaroo. Alright, there's the kangaroo. He jumps up and he comes back down. We know that he's going to travel 2.62 meters. That's how far he's going to go. Alright, and we know that we're trying to find the initial velocity equals whatever. We know a final velocity up here, if we kind of read into the problem, is 0 meters per second, because when it gets to the top it has stopped. It's very fast down here. It has a lot of kinetic energy, but it has no kinetic energy at the top, because that's where it's all potential. So it has the velocity up here then is 0. We also know that we have an acceleration of 9.8 meters per second squared, because gravity is involved in this picture. Now sometimes gravity is going to be negative, and sometimes we're going to consider it as positive. It depends on whether we need to look at it as a scalar or vector quantity. It's always a vector quantity, but we need to consider it as how we're using it. We're going to talk about scalars and vectors when I get back, but what you're going to see in a minute is why these are important and how they play into our considering that acceleration due to gravity sometimes negative and sometimes it's positive. Alright, let's go ahead and draw our little GES thing, and I'm not really adept at drawing these lines with this, but I'm going to try. Alright, I don't like that one. I'm going to redo it. Alright, I don't know what I just did. Alright, there you go. I hope you're happy. Okay, so the first thing we're going to do is write down our little things, write down the information from our problem. The first thing that I like to do is write down what it's asking me for. I know it's asking me for an initial velocity. It's giving me a distance of 2.62 meters. That's always good. Like I said, over here we've got some more information. We know a final velocity is 0 meters per second. That's good. We know that we have acceleration due to gravity. It can either be plus or minus 9.8 meters per second squared, whichever way we need to think about it. Now that isn't the best physics in the world, but for what we're doing, it's perfectly fine. When you get to college, there'll be more there for you to learn about all that. All right, and maybe before this year's out. Okay, but this information, as I look at it, I can't solve for velocity over here, the initial velocity, using average velocity, because to find average velocity, I don't have a distance and a time to find average velocity, and I'm going to need average velocity to find the initial velocity, because the only other thing I have is the final velocity. So this one doesn't work. I've got to find time. All right, here, and I can't find time here because I don't have an average velocity. So these two are out of the question. Now this one right here I can use because I have an acceleration. I have a final velocity. There's my initial velocity that I'm looking for. This is the one that I'm looking for. I have this one. I have this one, but I need this one. So if I need this one, I'm going to find it here because I have the distance and acceleration. So that's how you solve these problems. You just have to work your way through. You have to realize what it is you're looking for, and then this part of deciphering out which formulas to use and which method, which puzzle piece to put in first, that is in essence solving of a physics problem. And you need this information organized somehow. Often people will draw pictures. Sometimes they will list out their variables and all of their units and numbers and quantities and what the question's asking. But you have to find a way to organize it in your head. I like to do both. Well, actually, I don't like to do both. Often I won't draw the picture, but I love to do this. Whatever works for you, I don't care, but you're going to need to know that you're going to need to organize the information. Well, so back to our problem. We're going to solve this right here first. This distance equals 1/2 AT squared. My distance over here is 2.62 meters equals 1/2 9.8 meters per second squared T squared. Alright, now with that with that being said, I want you to see that I used a positive here because my quantities in my formula are, these are, distance is a scalar, time is a scalar, so I don't need to use acceleration as a negative number because these are scalar quantities that can only be positive. Vectors are the only things that can be, well, we'll deal with all that later, but these are scalar quantities, so I don't need to consider this as a negative. Well, so when I'm doing this math now, I've got, let's just start doing our little algebra here, and we've got 4.9 meters per second squared T squared, because all I did was take half of 9.8. Now I'm going to take 2.62 and divide it by 4.9. 2.62 divided by 4.9 equals 0.535 meters. Oop, no it doesn't, equals meters, you big goof. It's going to equal seconds squared because these meters are going to cancel each other out when I do the division. And then that's going to give me T squared. And then when I find the square root of 5.53, then I get 0.731, 0.731 seconds, because when I take the square root of this, the squares fall off. That's the whole point of it. Alright, so now I know that my time then over here is going to equal 0.731 seconds. Now I can start running my acceleration formula. No problemos. I need this little thing. Alright, so I got to erase all this, and it takes me just a minute. But while we're doing that, I want you to remember a minute ago when we used a positive for gravitational acceleration. Now we're going to use it as a negative number. And I'm going to change colors here just because I like to do that. Now I'm going to use the acceleration formula in here finally to solve my problem. When I plug in my numbers here, I'm going to use a negative 9.8 meters per second squared. And I'm going to show you why that can be, you can figure out why to do that, is because my velocity here, my velocity when I throw the, or when the kangaroo is, when he jumps up, his velocity is in this direction, but acceleration is in this direction. So velocity is in one direction, acceleration is in the other, so I need to consider them as opposites. And so to do that, when I'm writing this formula, my velocities over here are positive. Excuse me, I didn't need to write that V2 down there because I know that quantity. That quantity is 0 meters per second. And this velocity is going to be considered as a positive. I'm subtracting it, but the quantity itself is a positive, and my time is 0.731. Now, this all has to do with scalars and vectors somewhat, and but don't get too freaked out about it, because once you work these problems out, you would have seen that the negative would have gotten in the way, or you would have wound up with a positive number and it would have been a mess, whatever. You'd have wound up with a negative velocity, and that would have been fine if you'd have been thinking about acceleration being in the other direction. But either way, I just wanted to show you that acceleration due to gravity is most often thought of as a negative quantity. So when we do the algebra here to get rid of all this, I've got to multiply this side times 0.731. I've got to multiply 9.8 times 9.8 times 0.731 equals, and it's going to be negative 7.16, and when I do this, you'll see that that falls off. This is going to be in meters per second. This is going to cancel out one of these, and then I wind up with 0 meters per, well, let's just do it like this, and you'll see why, negative V1. Well, when I do this, this obviously falls off. Now I have all that right there kind of falls out. So I have negative 7.16, and equals a negative velocity. Well, that's just going to cancel out because 7.16 meters per second is now my initial velocity. And that's how I'm going to come to grips with that. Now you can see that if this had been a positive, then my velocity would have been a negative number, which it would have been a negative number considering the acceleration due to gravity was the other way. If this would have been positive, then this has to be negative. But if we consider this as positive, then this one has to be negative because they're opposites. All right, and that's the only reason that I did that. All right, so let's just see if our solution is good. Well, they've used the formula that you're going to have on your exam. They used VF squared equals VI squared 2AD. And you'll have that formula. But I want to show you that we can use these formulas to find it. There's different ways to get to the solution, but you'll see that we all arrived at the same solution, 7.17. We got 7.16, but that would have been due just to the rounding error after I had all of these numbers up here that I used and rounded to a little more less accurate significant figures. So, or whatever. Yeah, significant figures. So there you go. The main idea I wanted to show you was that you're going to make mistakes along the way. You're going to have to put the puzzle together. Hey, it's like putting a puzzle together. You have to find the pieces, and sometimes you have to spin them around and make them fit, and sometimes they don't fit easy. But this one right here would spin around this way and then slide it over and then slide it up. And that's what we had to do with these formulas, is we had to move them around, slip them around, put the variables where they belong and make everything fit so that we can get to our final answer, using one formula to get to another. Hey, I hope that confused you, because I'll be back Friday, and I hope that you behave. Have a nice day.